Hello and welcome to the series of an overview on precast construction technology, a Lego construction. So let us start with this video. So this will be our flow of the presentation, in which we will look we will go through the technology, what is the precast technology and its benefits, as well as its differentiation as compared to the cast in situ construction. Then second, we will go through the manufacturing process, where we will see the how molds are prepared, how the accessories are fixed in the element before the production, and then we will move on to the design and connection of the precast elements, where we'll see the how precast to precast or precast to cast in situ connections are connected, and also we'll see the connectors that are used. And next we will go through the product tolerances which IS code suggests. There are various tolerance that are accepted by the codes, as well as we will go through the logistics and erection, in which we'll see how the elements are lifted and erected in position. So first let us discuss the technology difference. So on the top you can see this is the traditional construction, where each and every activity is performed on site, where the wooden shutters or steel shutters are used to make to form the shape of the element on site. Where on the below you can see this is the precast construction technology, in which the elements are pre-casted in the factory, or the elements are casted off the site, where where the elements will be then transferred to the site by special transportation vehicles. So here it shows that each structural elements are pre-planned, executed, transported and erected in the position with the high accuracy of supervision and precision in controlled environment. So yeah, this is the precast technology. So this is the major difference, where in traditional construction, the each and every activity is performed on site, where shutters and everything is required, and there is a huge time consuming process. Whereas on the other hand, the precast construction is casted pre, or we can say it is casted well in advance, and that's the reason the precast technology saves more time, as well as it provides a good quality and durability as compared to the traditional construction. So this is all about the process. So if we talk about the process for precast construction technology, so it starts from the concept and planning, where each and every elements are well planned, and then it goes to the design and production, where elements will be designed and it will be produced in factory. And then it comes to the logistics part, where the produced elements, or we can say precast elements, are then and are transported using special vehicles to the site. And then it comes to the erection part, where the transported elements are lifted from the special vehicle, and then it is erected to the site using the cranes. And then the last point that comes into the picture is the handover, in which the structural when after the erection, the finishing of the elements are done, and then it is handover to the client. So we have there are many of the precast elements. We have already seen that the hollow core slab we have already covered in my first video of this series, and we have already seen the second video for the precast wall panels, whether it is load bearing wall as well as non-load bearing walls, whether it is insulated panel or solid panel, we have already seen in my second video. So if you haven't watched the series video starting from hollow core slab, we have already made the videos on precast hollow core slab, and also we have made video on precast wall panel. And in this video we will discuss about the precast and prestressed beam, that is known as the wet product. So here in the picture you can see this is my precast beam, and this is the precast columns. and this is the precast wall. So here we have in our in our precast wall video, we have constructed the corbels. This kind of corbels are given in the element to rest the beams. So here you can see this is a corbel, and above the corbel we have rested the beam. Here also you can see this is a corbel in the column. So in our upcoming video we will discuss about the column. So currently in this video we will discuss about the precast and prestressed beam, that is known as the wet mix product. So let us go through the various stages that comes into the picture. So the first stage is that the preparation of the mold and reinforcement. So the mold will be prepared as per the drawing, and side by side the reinforcement cage will be prepared. Coming on to the second stage, after the preparation of the mold and cage, the reinforcement cage will be lifted and placed into the mold, where all the accessories will be tied up, such as the lifting hook. So here in the picture you can see this is the lifting hook to lift the element, which will be used for transportation as well as erection purpose. Another fixings such as the double tubes that we have seen in wall panel video, that double tubes are used to connect the elements. Even though we will talk about the double tube connection in this video as well. And the third stage, that is delivery and erection of the element, where the casted elements will be transported on the special trailer, and then it is erected on position. So here you can say this is the precast column. Also here we have the precast column. Here it is the corbel to rest the precast beam on the both side, and this part will be rested on this two portion. So this is the beauty of the precast construction. Now let us see the how precast beams or prestressed beams are casted in the factory. What is the process? So here you can see this is the prestressed element, where this strand wire are used. See, these strand wires are placed in profile as per the design drawings, and here you can see this is the reinforcement cage that is placed in position, and then the shite shutter, this is the wooden shite shutter that is used as a shite shuttering purpose, in which the both ends will be closed. And here you can see the silver corrugated pipe. Here you can see that is known as the double tube, which will be passed throughout from the bottom to the top, in which the reinforcement that will be projected out from the column, that will be go through this tube, and this tube will be filled with the special grouting material, which is known as grout, to connect this element. So this kind of tubes on both side of the beam will be considered. And here you can see this is this picture, that in this picture the reinforcement cage is loaded on the mold, and then this two shite shutter number 1 and shite shutter number 2 are placed in position, and then our strand wire will be laid through starting from the live end to the dead end. So these are the strand wire which is passed throughout the prestressed element, where this wire will be locked using this special kind of locking system that we will discuss in our previous slides. So here you can see it is very important to provide the L bar to connect this beam with the with other elements such as column reinforcement and beam reinforcement has to be tied up to provide the structural requirements. So here you can see, as we have discussed, that there are strand wires that are laid on the bottom side of the precast beam. So these are the strand wires that are laid, and the important part is this L bar that has to be projected out from the beam to connect it with the column. So here you can see this is the pre-stressing beam structure, and numbers of beam are placed in at a time. There are roughly it can be constructed around 10 to 15 numbers of beam depending upon the length of the beam. And here you can see this is the lifting hook that is provided to lift the precast elements. So this is the special kind of locking system that is used to lock the strand wire. So here you can see this is known as the barrel, and this is the wedge. So this set is known as wedges and barrel setup that is used to lock this wire from both of its end. So after the locking the wire, the pre-stressing machine is used. So here in the right hand side picture you can see this is the pre-stressing machine in which there is a gun. So this is the gun through which the wire will be pulled with the required pressure. So here you can see this is the pressure gauge in which we have to set the pressure that is given as per the drawing, or we can say we have to set the force in which we have to pull this strand wire. We have already discussed how this elongation is measured and how this tracing is done, in how many steps this tracing is done. We have discussed all this thing in our first video, which is about the precast hollow core slab. If you want to clear this process, then you must go through uh, that hollow core slab video. And if we see the IS code which talks about the pre-stress wire, that is IS 14268/2022, which says about uncoated, stressed, released, low relaxation 7 ply strand for precast and pre-stressed concrete specification. So you can just go through this code. We have already seen the details of this code in our hollow core slab video. Now let us see the design and connection of the beam. So the beam can be either rested on the corbel, or it can be directly rested on the element as a bearing requirement. So figure A can be also known as infilled beam, or we can say corbel beam over the corbel. And second type of connection, that is known as beam spanning to column connection. That is column to column connection, where this bearing is required to rest the precast beam. So if in case of the in case of infilled beam, or we can say beam above the corbel, so this is our corbel that is projected from the column, and we have the precast beam like this. So in that case we don't require the L bar. So here we have seen that we need the L bar. So here you can see this is the L bar that we have discussed, that we need to connect, we need in use of the connection. But in case of figure A, that is known as connection, or we can say connection of precast beam with the corbel, in that case we have to use the double tube on the top to connect this. In that case this bar will be used to connect the beam, where in type B, that talks about the beam that is supported on the column. So in that case here you can see white color bar, that is known as the L bar, that is used to connect the beam with the column. So there are two types of connection that we have discussed. Now in the bottom of the figure you can see here it is a column, and it can be, there is a three types of beam that can be used. First, it is infilled beam. So here you can see this is the kind of corbel that is provided. So it is a kind of type A connection. Second, we can give as a cantilever connection. Here you can say this is the my column and this is the cantilever portion. So this either it can be a cantilever beam, as well as we have column to column connection, in which we have column on both of the ends, and the beam will be rested on required bearing. So this is the bearing on both side. minimum bearing is used. So this is the type B that we have discussed. Now in case of lifting the beams, we have already seen here that either we can use a lifting beam, sorry, a lifting hook. Here you can see this is the lifting hook that is provided to lift the precast or prestressed elements, either or we can use this kind of connection. This is known as lifting anchor. So it depends upon the element size and weight of the precast element. If the weight of the precast element is more, then it is suggested to go with the lifting hook, and if the element size is small and weight is less, then it is recommended to use this kind of special connection that is known as lifting anchors. So now let us see how the lifting anchors are fixed in position before concreting. So here you can see these are the lifting anchors that are placed in position. So how it is fixed? So here you can see this is the anchor that is connected with the reinforcement cage, and this is the clutch that is used to lift this particular kind of uh, fixing connections. And here you can see this is fixed in position before pouring the concrete, and this is the recess former that is used to create the shape, semicircular shape, to create the semicircular shape, and in that semicircular shape this kind of lifting clutch is used, and it will fixed, and then it will be lifted to demold the element. So now let me show you the clear picture. So yeah, so here you can see this is my this is the anchor that is used, and this is the recess former that I was talking about, the use of recess former. Here you can see this is the semicircular gap has been created, that is used for fixing this kind of clutch into the position. So here you can see this clutch is fixed in position, where this anchor has been locked with the clutch, and it will be lifted using the crane. So here you can see this is the clear picture, and it is very important to fix this kind of elements. So here I will show you the physical one. This is the lifting tool. This is the recess former that is fixed in position, and here you can see in this kind of, this is our precast beam, and this here it is the lifting hook that is provided, and it is lifted using the crane. So now this is the precast column that is placed in position, that it has the corbel connection. So it will be a kind of type A connection. So we have this kind of connection that we are looking into. So here you can see this is the corbel connection that is provided, and from the corbel there is a two reinforcement that is coming out, that will be connected through the double tube provided in the precast beam. So now here you can see a clear picture in which we have the corbel connection. This is the corbel on both of the ends here, and we have the precast beam over here. So this is our precast beam. From here corbel there will be a reinforcement that will be pulled that will be projected out on both of the side, and we will have the dowel tube over here which will be connected, and the concrete or special grouting material will be filled in this tube to connect this element. So here you can see one of the site photograph. So here this is the precast column with the corbel on both of the sides, and we have the precast wall panel, that is solid wall panel with the corbel, and above that we have this precast beam with the nib. In this is the nib portion, and above this the hollow core slab will be laid like this. So here you can see fully concept that can be understood easily. Here also you can see this is my precast wall panel 1, this is precast wall panel 2. It has the corbel over here on side 1 and side 2, and there is a precast beam that is fixed above this corbel. even though you can see this is my wall, we have the beam over here, and similarly we have beam over here. And next, if we see, this is the column, this is the column with the corbel, and we have the precast beam over here. So let us discuss the product tolerances. So if we talk about the product tolerances, we have the manual, that is manual 135, that talks about the tolerance manual for precast and prestressed concrete construction. So here you can see this is the width of the beam, that is shown as B. It can be a rectangular beam, it can be an inverted T beam, or it can be a L beam, depending upon the requirement. So what the code suggests is that the length variation should not be, or we can say the length tolerance shall be plus or minus 19 mm. The width of the, or we can say the overall width of the beam, can be tolerated and as plus or minus 6 mm. We have the steam width as plus or minus 6 mm. The overall depth is plus or minus 6 mm. So these are all the parameters that has been suggested by the manual 135 as a product tolerance. So this was all about the precast and prestressed beam. So thank you so much. If you haven't watched the video of hollow core slab, then you can must watch our video on hollow core slab, as well as we have also the precast wall panel video. So you can go through this series in which we have hollow core slab and precast wall panel, and we have already discussed about the precast and prestressed beam in this video. And we, in our upcoming video, we will also see the precast columns, we will see precast staircase and landing, we will also see the various testings on hollow core slab, and more about the precast technology. So thank you so much for this video. If you have liked this video, please share me a thumb and comment the requirement that you want in the future, and share with the others, which will be benefit to others. Thank you so much for this video. Thank you.